Welcome all. Now I am going to discuss question number 32 from the GATE 2019 paper Electrical Engineering. The question is, a moving coil instrument having a resistance of 10 ohms gives a full-scale deflection when the current is 10 milliamperes. What should be the value of the series resistance so that it can be used as a voltmeter for measuring potential difference up to 100 volts? These are the given options. To know the detailed concept of range extension of voltmeters, audience can go through the given NPTEL video link. Let us discuss some useful information to solve the problem. For a particular design of a voltmeter, internal resistance of the voltmeter is constant. Also, the full-scale deflection current passing through the voltmeter is also constant. So, to extend the measuring range of a voltmeter, we need to add a external series resistance such that the current flowing through the voltmeter should not exceed the full-scale deflection current. So, using this information, let us solve the problem. Given data, what it is given? Given it is internal resistance of the meter is 10 ohms and also the full scale deflection current is 10 milliamperes. 10 milliamperes, and it is asked to find out the series resistance needs to be added for voltage 100 volts. This is the block diagram of a voltmeter. This current is the full scale deflection current and this resistance is the meter resistance or internal resistance of the voltmeter. This is for particular voltage. This is for particular voltage. So we need to extend the range of the voltmeter. So how the range extension can be possible? By adding an external meter resistance, we can extend the range of the voltmeter. This is the V extension and this is the R series. This resistance value we need to find out in the question. So, first we need to find out the how much voltage the actual voltmeter can withstand. That is, V full scale deflection is equal to I full scale deflection current into internal resistance of the meter or the meter resistance, that is 10 milliamperes into how much the internal resistance? 10 ohms, that is equal to 0.1 volt. But then we need to find out the extension value. So V extension is how much? V extension is 100 volts. So 100 volts, right? V extension is equal to 100 volts is equal to current passing through the meter is always constant, that is full scale deflection current into the series resistance needs to be inserted plus the meter resistance. So 100 is equal to full scale deflection is 10 milliamperes into internal resistance of the meter is how much? 10 ohms plus the meter resistance. So if we simplify, we will get the series resistance, external series resistance as 9990 ohms. So this much of external resistance needs to be added for the range extension of the voltmeter from 0.1 volts to 100 volts. So the series external resistance needed is 9990 ohms. Thank you.